got one pentene. Yeah, because the parent starts right there with the double bond on carbon number 1 between 1 and 2. So it's one pentene is the parent. And then we have that chlorine on there as well on carbon number 1, which has already been numbered because of the double bond presence. So yeah, this would be not just 1 chloro, 1 pentene, but since the double bond is on the same side of the double bond as where the parent was, this would be cis 1 chloro, 1 pentene. And if the chlorine was down here, it would be trans 1 chloro, 1 pentene. I have 2 isomers, geometric isomers of a polymer. Now we haven't gotten into polymers yet. We'll talk about polymers in a week or so. But polymers' names always start with poly, like polyethylene, polypropylene, polyurethane, that kind of thing. So those are polymers where they have real long chains. This is an example of where we have cis and trans isomers and how they have different properties. Now I'm making this big deal about just replace the hydrogen with the chlorine and switch places, and who cares? Well, it turns out that they have different properties. They're different substances. They're similar, but that doesn't mean they're the same. So an example would be the trans isomer of polyisoprene. This is a natural rubber, is what this is. And so the trans addition looks like this. The cis addition looks like this. I want you to check out both of them. You can take some of this out if you want to. And stick your hand in there and feel the trans. And make sure that you smell the I guess this one is the trans. They don't even smell the same. So check those out. Pass those around. You'll like the smell of that trans one. Am I right? Yep, smell good? All right. Okay. So while that's going around, I'd like to just show you a couple of examples of some double bonded compounds here and see if we can name them with the cis trans. So let's walk through this one together. First thing is, anytime you have to name an organic compound, you identify the parent. Don't start getting fancy and trying to do different things here as you get to know these. Always identify the parent first. And I would suggest, I always do this, put a circle or put some notation to show yourself where the parent is. Now I am going to ask you to not write in your book. I know that it's tempting, and in fact I'm encouraging you to circle things and mark things up on the problem. But please, we want to take care of our textbooks. They need to last us about 10 years. And they cost $200 or more each. In a few years, they'll be probably $220, $230 somewhere. I think they're around $200 right now. So they're very expensive, but please take care of those. Anyway, what is the name of the parent in this molecule?
Butene.
It's butene. Not just butene, though. One butene. One butene. Carbon number 1 is right there because we want to minimize the numbering of the carbons. And then we have that functional group. So there's only the one functional group on this parent chain. It is another chlorine. And since the parent was above the double bond on the left side, the chlorine is also above the double bond. And when I say above, I just mean that it's on the same side as where the parent was coming into the double bond. Cis or trans?
Cis.
Right, it is a cis isomer. So that, now if we have the Cl and H change places, then the Cl would be down here. It would be on the opposite side of the double bond where the parent was. That would be a transposition. Remember, the naming of organic compounds is always done with the same system. The parent always goes at the end. The name of this parent is 1-butene. The 1 goes with the butene because it's part of the name of the parent. And then out in front is the location and identity of any functional groups. So the functional group is a chloro group. It's on carbon number 1 in the parent, but also we need to specify, because there was a double bond there, that it is where it is around the double bond. So it is cis 1 chloro and then 1 butene. So if I were to come in here and ask you, okay, can you draw the structure of cis 1-chloro-1-butene, everybody would have something like this. Then we know what side of the molecule the chlorine goes on. We know what's attached to what, and the whole thing. Okay. Oh, okay. All right. Anybody have any questions about that? So yeah, remember, functional groups, where they are and what they are, and then the parent chain comes, or the parent of the molecule. Now let's try one that I'll just be quiet here and let you give a shot too.
Oh my god.
What do you think? Pretty nice.
Oh.
Did everybody have a chance to check out? So you see they're very different properties. Sometimes they're more similar than this, but this is a great example of how different they can be. Now they're both kind of stretchy. You know, they have similarities, but then there are things that are very different about them too. Try that. Have it?
Almost.
What is the name of the parent in this molecule? Heptene? Give me more specific. 3-heptene. 1, 2, 3. It's going to be 3-heptene is the name of the parent. So I'm just going to go ahead and identify that. Then how many functional groups are on there? Just one. It's right there. Okay. Well, the parent is 3-heptene, but probably we should be more specific even about the name of the parent. See how the chain is arranged or organized, situated? We have the double bond here. Started the parent started above where the double bond is, but then it continued after the double bond down below. So what would we use to describe the way that is arranged? Trans, right. The parent is trans 3-heptene. Are you with me? Now, remember how I was just making a big deal about the parent comes last with the identity and location of the functional groups first. Trans is part of the name of the parent, so that should go with the parent, the trans part. We have one functional group which should go out in front, and that is a methyl group. What is the location of the methyl group? You're saying 2? No. Remember, the double bond got the priority for the numbering, so this has to be carbon number 1. Yeah? Double bond gets the priority. So that carbon is carbon number 6, where the methyl group is. So the name of this thing. 6-methyl. There's our functional group with what it is in its location. We get that first. And then the parent is in the end. Trans 3-heptene. Yes, ma'am.
Why do we put trans in the middle for the second one, but we put cis at the beginning for the first
Okay, because remember, the system that we use to name these things, the parent always comes last. And then the functional groups with where there comes first. In this bottom one, the name of the parent is trans 3-heptene. So that comes last. Over here, the name of the parent is 1-butene. The cis is there to tell where the chlorine is,
Oh, okay, that makes sense.
which is a functional group. So the
Right.
functional group location comes out in front.
Okay.
All right, now, having done all that and making a big deal of it, I'm going to tell you this, and this is true. I'm not going to make a big deal of where you put the cis and the trans. If you put it in there, if you put it at the end, butene cis, I'll be so happy that you remembered. I won't even mark you wrong. Okay? Just try to remember when you have that double bond and the arrangement of the molecule about that double bond. Just try to remember to put it in. Like if you put the trans out in front here, said trans 6-methyl-3-heptene, no problem. Okay? Yeah.
How'd you get the three?
Oh, because this thing, the part that I have circled in red, that's heptene because the hept because there are 7 carbons, ene because it's got a double bond in it, and the 3 is to tell where the double bond is. It's between carbons number 3 and 4, and you minimize the number, so it's 3. Okay. Well,
So why isn't it just trans 2-methyl 4-heptene? Because that would be less numbers, like the lower numbers.
but you're right, that is true. But the double bond gets the priority.
Okay.
So yeah, I mean, I know there may be functional groups on here, but yeah, the parent is matters more. Yeah.
If the functional group was on the left side of the double bond, would we have put methyl after trans?
No, because the trans is still part of the name of the parent. So this should come last with the name of the parent. Okay, great questions. Yeah, trying to sort all this out in your brain. I get more questions about cis-trans and geometric isomers than anything else in the chapter. This just hangs people up. And I'm not saying, oh, what's the matter with you? This is easy. It's not easy, it's hard. It's very hard, as you see. Just practice the problems. You might want to spend some time in doing other problems that are in the book that are not assigned, because you have the answers there, just as you try to work this out in your head until you feel like, okay, I think now I have the system and know what to do. Because we assign problems doesn't mean you can't do the other ones. It's just not going to be quizzed on, but you still probably want to do additional problems just to reach that comfort level. There's one in the book. Hopefully you've started doing some of these. I'm going to show you number, oops, I just did it wrong. 27B. If you did this over the weekend, then you may have been left thinking, oh man, I've got something here that I didn't see before. 27B, give the structure for 2,4-heptadiene. Anybody see that over the weekend? Yeah. And we hadn't done anything like that. What's that di doing in the middle of it? Okay, I can understand heptene, but heptadiene, well, what does the di mean? There's 2 double bonds in that pair. Yep, yep. So I did it up here. This has got 7 carbons. There is a double bond after carbon number 2 and after carbon number 4. 2,4-heptadiene. So diene because it's 2 double bonds. Now, I did this one first, and I just put this up last hour. I thought, oh, I'll just keep it up here because I want to talk about it this hour. Keep in mind, and this is so simple, but it's powerful, carbons always make 4 bonds. So when you're checking your structures, make sure that every carbon has 4 bonds on it. So this may not, you may not be to this point yet in writing structures. It's totally fine if you're not. Write the carbon with the hydrogens flared off of it until you feel like you can do this and be comfortable with it, okay? And I didn't put all the H's on there. I just left these off. So yeah, this and this are the same thing. We have C with 3 H's around it and bonded singly to that one. Now, there's a double bond between those. That carbon's got to make 4 bonds, so it can't have a hydrogen above and below because one of the bonds is making a second bond there with the carbon next to it, okay? So we have 4 carbons there that only have 1 hydrogen on them because of the alternating single and double bonds. Now, we can count up what the chemical formula is of this thing. It would be C7H12. 12. I think there's 12 hydrogens on there because of the presence of the two double